Okay, welcome back. And in the last video, I finished by writing this up top. Central angle, the central angle measure equals the intercepted arc measure. And so now let's use this. And so let's go through problem number 1. And so the idea here is we just want to put the degree measure on all these blanks for all these arcs, and we got to figure it out. It tells us that MQ and NR are diameters. And so this line here cuts the circle in half. Each side will be 180, remember that. And then NR cuts it in half a different way. Each side of NR will also be 180. So we'll use that in various ways. But here's how I believe is the best way to go about starting these problems. See how this circle is kind of like a pizza, and it's cut into like different pizza slices. Obviously, it's been cut into 4 pizza slices. They are not all consistent, but that's just kind of the idea. And the center down here is our central angle. So that's kind of where our pizza slice becomes, the tip of our triangle. And that degree measure is going to equal what the crust of our pizza at that slice equals. And so R to Q is going to be 63 because the central angle was 63. Remember, central angle equals arc. And so what I think is the best plan for all of these problems is fill out all the different chunks of this circle, both the angles and the arcs. And then once the entire circle's filled out, we can come back to the problems over here, A, B, C, and so on, and we just follow the letters. And we just add together whatever numbers come in between the letters that we're following. And so let's start with that. And so if that one was 63, then its arc was 63, right? If the pizza tip is a number, the crust part of that pizza is the exact same number. So same deal with the 82. Since the angle is 82 there, from N to P is going to be 82 as well. Now, there's going to be various things you need to remember to be able to fill out all these circles. A couple of them would be vertical angles and linear pairs. Remember, vertical angles are across from each other at an intersection point. And so that's like this right here. That's 63, and then directly opposite of that 63, they are across from each other at the intersection of our 2 diameters. And so we call those vertical angles, and vertical angles are equal to each other. So since the one side 63, this other side 63. And then remember, angles equal arc, and so where MN is, that arc is 63 as well. Now, that's a discussion of vertical angles. Here's a discussion of linear pairs. If we look at this diameter, and maybe I'll make it a little thicker here, M to Q, and I want to look on the right side of it. That's where the 63 is, and then this blank angle. Those are 2 angles that together form a straight line. We call that a linear pair, and linear pairs always equal 180. Another way to know that it equals 180 in this context is MQ is a diameter, right? And so diameters cut the circle in half. If the full circle is 360, then half of the circle is 180. And if part of that half is 63, then we do 180 minus 63 to get what the other half is. That would be the arc from just M to R. And remember, the angle is exactly that same measure as well. And so let me clear this kind of up. But these are vertical angles in linear pairs. Vertical angles are equal. The one we're working with right now is going to be a linear pair. And so this angle right here is going to be, oops, this was 63. But again, this angle right here is going to be 180 minus 63 because those two form this straight line. And 180 minus 63 is 117. So this angle is 117. And remember, angles and arcs equal each other, and so this arc is 117 as well. And then lastly, we need to work through a triple supplementary situation. So I'll change this. If I look at this blue line, that's a diameter. It's cutting this circle in half. And so the bottom here, this whole bottom half of our circle, has to equal 180 in total. Well, that 180 is an 82 part, a 63 part, and a blank part. All 3 of those parts have to equal 180. So if I do 180 minus 82, and minus 63, right? I just want to subtract away those two parts that I know. It'll leave me with the part I don't know. And so 180 minus 82 minus 63 looks like it's going to be 35. 35. And so let's clean all this up. 35. And so that makes this arc 35. Angle and arc equal each other when it's a central angle. So that angle's 35. And I accidentally got rid of the 6 and 63. And so now we've got all the parts, right? If I look over here, I've got every single one of my angles filled out, and I've got every one of the arcs filled out with the same number because they are equal. And now let's go over here to the A, B, C, and so on, and we'll just piece it together. So arc MN, that's just from M to N. Follow the letters. That's 63. Oops. 63. And then NQR, again, just follow the letters. NQR, follow the letters. And so that would be from N to Q to R. Now, that would be, right, that covers an 82-degree section, 35-degree section, and a 63-degree section. So we just want to add those together. 82 plus 35 plus 63. But we should notice that that line is a diameter. It's cutting this circle in half. And so all three of those numbers should add up to 180 anyway, because it is a semicircle. That arc is a semicircle, is exactly half of our circle. And you will get 180, again, if you add all three of those numbers together. All right, so let's clean up the circle a little bit more, and let's keep going. I'm going to probably go a little bit quicker now. We'll see. And so here we go. QR, follow it. Q to R. Q to R, just 63 again. And then QMR, so from Q to M to R. And so from Q to M to R almost brings us around the entire circle. We are just missing this 63-degree chunk. Well, the entire circle is 360, and if we're just missing one chunk, let's subtract it away. And so that whole thing, which is most of the circle, is going to be 360, and then we're just not counting this 63 part, so we're going to subtract it away, and that leaves us with 297 degrees as QMR. Again, you could just add everything together as well. You could do 35 plus 82 plus 63 plus 117. That will equal 297 as well. And so different ways to go about this problem. And I just want to show both of them. All right, so let's keep going. PRN, P to R to N is almost the whole circle again. This time we're just not counting the 82 part. So let's do 360 minus 82, and that will equal 278 degrees. Let's go NQ. NQ is going to be the 82-degree section and the 35-degree section. So 82 plus 35 is going to equal 117. Perfect. MRP, so from M to R to P, that's a bunch of sections. That's 117 plus 63 plus 35. In total, that equals 215. MR, MR is just one section, M to R, so that's just 117. PQ, again, also just one section, that's just 35. And MQN, M to Q to N, that's everything except for this 63-degree section. And so we'll do 360 minus 63 again, and that will give us 297. All right, let's go through the next one. This one's kind of tricky. I'm going to cross off this 30 because that 30 really applies to this small little section. And now let's go through this, right? Angles equal arcs. So this is a 30 as well, where we see the 70, the M to N. That should be 70 as well. 70 and going straight across the center, that's a vertical angle. They have to be equal to each other. So this will be 70. meaning the arc is also 70. The 70 up top mixed with where the O is, those are two angles that form a linear pair. They should add to 180. So where the O is, that angle has to be 110, which means the arc from M to R is 110 as well. And then finally, the last number we need would be like, if I put this back in, the bottom half has to equal 180 in total. It just has three parts, a 70-degree part, a 30-degree part, and then something else. Again, it needs to equal 180 in total. So 70 plus 30 is just 100, which means this side should be 80 because 100 plus 80 is 180. And then N to P, the arc is going to be the same. Perfect. So let's go through this quickly. We don't have much time left. M to N is just 70. It's just one section. NQR, so from N to Q to R. It covers three parts, 80, 30, and 70. If we add those together, we will get a 180. And we can tell because from N to R just connects our diameter, right? Which splits our circle in half. Half of a circle is 180. And then Q to R. Q to R is just one section. It's a 70-degree section. Q to M to R. Q to M to R is almost all of the circle except for not the 70-degree part. So we'll do 360 minus 70, and it leaves us with 290 degrees. Perfect. PRN. PRN. So from P to R to N. Again, that's most of the circle. It's just not counting this 80-degree part. So I'm going to take that away from 360. 360 minus 80 is going to be 280 degrees for this one. And then N to Q. N to Q is a two-part section, 80 and 30. And 80 plus 30 is 110 degrees. Perfect. MRP. MRP. So M to R to P. That's three parts here, a 110-degree part, a 70 part, and a 30 part. 110 plus 70 plus 30, that equals 210 degrees. 210 degrees. MR, just one section, that's the 110-degree section. PQ, again, one section, that's just the 30-degree section. And then M, Q, N, M, Q, N is almost all the circle, just not the 70-degree part. So we'll do 360 minus 70, and that will leave us with 290 degrees. Perfect. So I think the crucial thing here is to recognize central angle equals intercepted arc. And so the same numbers we put as our angle numbers in our circle, that's what we want the arcs to be. And then just go through the list and follow the letters. And if it's just one section, that number is the answer. If it's multiple sections, we just need to add those numbers together. All right, last piece. We need to use that idea to solve for x as well. And so here we go. What you'll see here is if we look at C to B, that's going through the center, so that's a diameter. Diameters cut our circle in half. And so this whole half up top needs to equal 180. And we have two parts that put that together, the 3x plus 20 and the 2x part. And so if we just add them together, 3x plus 20 plus 2x, the total should equal 180. And combine like terms, 5x plus 20 equals 180. Subtract 20 from both sides. We got 5x equals 160, and then we'll divide by 5, and we get x equals 32 in this example. Now, not only do they want us to solve for x, but they also want us to find arc AC. And so AC is just this one, follow the letters. That's the 3x plus 20 piece. And so arc AC, measure of arc AC, will equal what we get when we plug 32 in for x. So 3 times 32 plus 20. And so that will equal 116 degrees, and we will finish this